Good morning. I'm going to kick off this session by providing some background information on where port electrification, or more specifically, onshore power systems for ships currently stands. A couple of caveats before I start. First, I know Texas and California have very, very little in common, but I am going to be talking about a number of the shore power activities that have been mandated by the California Air Resources Board, or CARB. Right now, California ports are providing the most plug-in opportunities, they have the broadest mandates, and they have the most lessons learned. All of my remarks are focused on high voltage shore power systems, 6.6 thousand volts, which are primarily used in the US, and 11,000 volt systems, which are primarily used in Europe. And cruise ships are the largest segment of the maritime fleet currently plugging in, both in the US and globally. Although in California, many container ships are also plugging in due to CARB mandates. Bottom line up front, the number of installed and planned onshore power systems are growing, both in the US and even more rapidly in Europe and Asia. Most of the onshore power systems installed so far have mandated that vessels use them or plug in order to reduce ship-generated air emissions and reduce port community health risks. And where provided, the cost-benefit analysis calculations are often favorable due to these public health and carbon reduction aspects of the analysis. That said, there are some recent examples where ports and ship operators have identified win-win opportunities for installing well-planned onshore systems that are comparable in energy costs to ships not plugging in. The first onshore high-power system was installed in Juneau, Alaska, about 25 years ago. At least that's what they say. There, the Alaska Light and Power Company, which powers the city and the borough of Juneau, as well as the onshore power system for cruise ships, is reliant only on hydroelectric power. This is a very isolated grid, and again, they have very few energy sources other than the hydroelectric power. In California, shore power, or what they term alternate marine power, has been available in the Port of Los Angeles for 20 years. The EPA conducted a technology assessment, a shore power technology assessment, in 2017 and updated that assessment in 2022. There's a lot of information in the 70-plus pages of this assessment, along with cost-benefit analysis. There are far fewer shore power plug-in opportunities in the U.S. than you might envision. There's over 300 commercial ports in the U.S. via MARAD, and there really aren't all that many opportunities right now for vessels to plug in. Most of the benefits highlighted in the EPA's assessment are emission reduction related and reflect community health benefits associated with reduced illnesses. And all of the ports identified on this slide with high voltage connections have a local mandate to use the systems as much as possible. Now, as I mentioned before, the majority of vessels consistently using shore power in the US and globally are cruise ships due to their high hotel loads, their regularly defined schedules and voyage plans, and the terminals they go into are also defined. This chart is taken from the Cruise Lines International Association's website. It shows where worldwide there are cruise ship berths with onshore high voltage systems. The information is current as of October 2024, and it shows a growing number of ports in Europe with active, which are the green shore power systems, funded, which are the black shore power systems, and planned systems, which are those in blue. Much of this growth is as a result of initiatives like the individual port decarbonization plans, national plans like China's current 5-year plan, which targets onshore power, and EU requirements, and the Fuel EU maritime regs that took effect in January 2025 that impose life cycle greenhouse gas requirements for ships, and by 2030 requires passenger and container ships to connect to shore power for any stay longer than 2 hours. This slide is sort of a highlight of the specific individual ports. I don't have a graphic showing container or other non-cruise ship onshore power, but in addition to the Chinese and the Korean ports showed, Singapore, Japan, and others are looking to install or have installed shore power. Asia is growing onshore power similar to what Europe is doing. From my experience working with cruise lines, however, not all of the onshore power systems in the U.S. are able to provide firm, which is available at all times power, and adequate levels of power. And not all were really well planned with an eye towards the future. For example, in Red Hook, Brooklyn, only half of the vessels that regularly call there can plug in due to tides, the ships where they have their plugs not being aligned with where the fixed terminal plug is, and most importantly, because of grid stability issues in Brooklyn. In Juneau, which again relies on carbon zero hydroelectric power, only 2 berths, the Princess Cruise Lines and the Holland America berths, have shore power. And there's often more than 5 cruise ships in Juneau at a time. Additionally, onshore power in Juneau is not available in times of low water, usually towards the end of a cruise ship season, during dry years, and when maintenance is being done. Last summer, 6 weeks, there was no shore power available in Juneau. When a Princess or Holland America ship plugs in Juneau, it's equivalent of another city of Juneau plugging into the grid there. In California, cruise lines and container vessels have made substantial vessel infrastructure investments to enable their ships to plug in and meet CARB emission reduction requirements. More than 120 cruise ships that are members of CLIA, about 46% of the total fleet, have installed systems for accepting shore power. Despite having these systems installed, commissioned, and available, cruise ships were asked not to plug in due to heat emergencies, wildfires, and other times when grid stability has been in question. Additionally, container vessels have also seen an inability to plug in despite having installed systems. The vaults, which is where a ship plugs into in a substation, were not planned with the current length of container ships, so many of them are unavailable for someone to plug into. And additionally, the substations don't have enough juice to power more than 1 container ship. This lack of adequate, reliable, and firm power and future needs planning has forced vessels that were planning on plugging in to instead burn MGO while in port, or for container ships and car carriers to use one of the limited numbers of expensive emission barges to suck up the ship's emissions via a bonnet, or I've heard it called a contraption, that fits over the vessel's stack. This is a double whammy, as these unplanned vessel emissions require diesel generators on MGO, which negatively impacts a vessel's carbon intensity scores, and capital that was installed and outlaid to install a shore power capable system is unused. I'm at the end of my allotted time, but in summary, the number of installed and planned onshore power systems are growing more rapidly in Europe and in Asia than in the US. Most of the onshore power systems installed have mandated that vessels plug in order to reduce ship-generated air emissions, improve port community public health, and/or to achieve port decarbonization and its goals. Cost-benefit-wise, analysis calculations are favorable due to the public health and air emission reduction aspects of the analysis, although ports have had a win-win with a vessel operator. specifically in Miami, a multi-organizational partnership between the port, 5 different cruise lines, the Florida Power and Light Company, supportive local politicians, and federal and state grants. I think it was mentioned before that it is going to take government intervention. That was to the tune of $22 million, enabled more than 21 ships with 350 port calls to plug into Miami in 2024. I think new nuclear, small modular reactors with small emergency planning zones will have to be part of the port electrification and decarbonization future. And that in a number of places right now, floating nuclear power plants make tremendous sense for firm, reliable, adequate, decarbonized, known cost, resilient, and when needed, possibly mobile power, in addition to possibly producing clean hydrogen or other synthetic fuels for a green port infrastructure. So thanks for your time and your attention. I'm happy to take questions during the panel session.
Thank you. So thank you, Admiral Servideo, for your presentation. It's very useful context to, I think, what will be a very exciting panel this afternoon, I think it is now. So as Toby mentioned, my name is Sanjana Shashikumar. I'm a senior regulatory analyst with Core Power's team in Washington, D.C., and it's my pleasure to be moderating the panel. Joining me today, we have some distinguished guests from the maritime and nuclear industries who will help us explore floating nuclear power and its potential to revolutionize the energy supply and resilience in port applications. So along with Admiral Servideo, we have Eric Carrero, president of the Greater Houston Port Bureau, the largest port by tonnage and the largest petrochemical facility in the United States. Lauren Latham, the advanced nuclear program manager from Southern Company, and Jeff Pollock, chief strategy and sustainability officer at the Port of Corpus Christi Authority, where he leads the port's energy transition and decarbonization strategies. Let's give them a round of applause as they join us on stage. So to reiterate an important point from Admiral Servideo's presentation, ports are facing increasing energy demand, sustainability goals, and the crucial need to provide energy resilience. Floating nuclear power plants with advanced reactor technology offer a promising solution to these energy challenges that have not been historically viable. Today, we'll be exploring this opportunity where power can be transported and delivered to where it's needed, including this crucial sector of the maritime industry. So to get us started for the panel, just to provide some more background, what is the current energy demand ports are experiencing, and how is it expected to grow in the next 20 years? And given the operational infrastructure, what would this increasing demand have on utility companies providing power to these ports?
So I can speak from a utility perspective, obviously, but very interested in understanding better the specific port needs. You know, David mentioned it, and our peers are seeing it as well, but the demand growth that we're seeing right now, we haven't seen in decades. And we're going to make a lot of interesting decisions over the next 10 years to try to meet that need. But one thing I think a lot about is how we can kind of change the way we think about our partnerships with the ports in our territory. So to make it really personal, I'm born and raised in Birmingham, Alabama. And so I think sometimes a lot about how Birmingham became the town that it is, that I grew up in, right? And one of the main things that drove Birmingham, it's a huge boon after Reconstruction, right? So we got within 5,000 people of Atlanta. But then in 1941, a small company that was out of Louisiana needed a new place for its headquarters. So that's when, for a number of reasons I won't go into, Delta Airlines put its headquarters in Atlanta instead of Birmingham, which was actually its first choice. And you think about the weight and the gravitational pull that airport in this case, right, but similar access to transportation and what that means from a global economy standpoint. that what that did to the city of Atlanta in comparison to what it did to Birmingham, right? Birmingham International Airport brings in $1 billion of economic development for the city, while Atlanta's brings in over 50 billion a year, right? And the difference there is astonishing. So it makes me think a lot about how we can work differently together and bring that same, an additional gravitational pull towards our seaports, even more than it is now. You know, the relationship in many ways that we have now is that, you know, ports are at the end of a wire of ours. And, you know, wires are the first things that go down, right? So how we think differently about that, I think, will be really important in the future. So we can have that paradigm shift like we saw when, you know, a new port took a new stance in a new town and it changed, you know, the future of that town.
Thanks. So if we're going to go down the line, just before I start answering, is anyone else here from a port or port authority? So we have total carte blanche up here. No accountability at all in the room. Okay. So look, you know, the answer to the question of what does emerging load look like is gigawatts. But I think what's more important than that answer is how that takes shape geographically, how it's distributed around a port region, number one, and then secondarily, what form it needs to take. And your mention of the vulnerability of wires sort of speaks to the heart of that. If you think about supply chain disruptions, port, you know, you've seen one port, but we all deal with some version of a supply chain story. And I think this idea of supply chain sort of like bust into the global consciousness. And sometime in COVID, you know, my youngest was 7 at the time, and he'd drop something, come out of the refrigerator, and he'd be like, oh, supply chain problems. So I think the importance of talking about how to fortify operations in ports is at the heart of this conversation. So, you know, in one of the earlier panels, there was the conversation about, well, if you're talking about gigawatt scale need, then maybe you should just be talking about sort of, you know, Gen 1, Gen 2 approaches to nuclear. I think that it's much more nuanced than that. I mean, I think we're talking about gigawatts in aggregate distributed across individual project sites and individual terminals. So I still think that the answer is in rapid deployment, firm but dispatchable service. But I think the answer still is in sort of modular chunks that are measured in double-digit or low triple-digit megawatts. You know, far be it from me to contradict the Admiral, but in our case, supporting the load that electrified vessels represents is like the last thing on my mind. I think the capacity to island individual facilities and offer resilience where we haven't historically had it, I mean, that has tremendous appeal in addition to all of the benefits that you heard, you know, as we talked, for example, about Exxon and the opportunities to provide heat to an individual production facility. I mean, for us though, those stories, how you can island facilities that's, you know, that is top of mind for us in the port. So it's not about what the size of the load looks like, it's about how we're going to fortify our service for it. So.
Thank you. Let me just give you a big picture of who we are as the port of a Houston region, right? We have Houston, Galveston, Texas City, and Freeport in our port region. We are the #1 petrochemical complex in the U.S. We are the #1 port by tonnage, #5 container terminal, largest in the Gulf of Mexico, and also currently we are the #4 cruise ship terminal down in Galveston. So as of 2022 study, we generated about $400 billion to the Texas economy and about $906 billion to the U.S. economy. When you look at those numbers and then we try to bring 2024 with the growth that we experience in this area, we're talking about $1.1 trillion to the U.S. economy, about 3.5 million jobs directly connected to our ports here in Houston, Galveston, Texas City, and Freeport. Our current energy demand, as you can imagine, yes, is a lot, right? We need to look for alternative options available currently and in the future. And I was talking to the panel about what that means for us, right? What's the future is looking for Houston? Well, the first week of January, the container ports at the Port of Houston, they had record-breaking 13,000 movements in one day. That was record-breaking. A week after that, 16,000 movements. So that tells you that, yes, we're still growing. Right now, 2023 in Galveston, we had 1.4 million passengers, record-breaking. Last year, we finished with 1.7 million passengers. In November 2025, a few months down the road, we're going to have a new passenger terminal down in Galveston. MSC Cruise Line is going to have their own passenger terminal. That means that we'll be at 2 million passengers a year terminal down in Galveston. Right now, we're number 4. I'm very sure by 2026, we're going to be top 3 in the nation. That tells you how much we're growing. On top of that, I'm not sure if you guys heard about Project 11. Project 11 is the 11th expansion of the Houston Ship Channel from 530 feet wide to 700 feet. That means we're going to be able to bring larger vessels, larger containers, ships into our ports. So the 16,000 truck movement that we had one day, that's going to be a theme of the past. We're going to continue to grow. And everybody knows Houston is an energy port. As the energy demand in Asia is growing, so is our supply here. So I know for a fact that, yes, our demand for energy at the port is going to continue to grow. And I'm glad we're having this type of conversations because we're talking about in the next few years. This is not going to be 20 years down the road. We're talking about in the next 3 to 5 years, we need to look for options to support our ports.
Excellent. So that actually flows quite nicely into the next thing that I wanted to talk about, given the increasing energy demand and the need to fortify. Crucial to the design of FNPPs is mobility. Current plans have them being built in central facilities before being transported to where there's power demanded, before operating and then being decommissioned. So what makes energy mobility attractive for this specific application? And how does it contribute to this fortification and to energy resilience for port operations?
Yeah, thanks. Here we go again.
Oh, no.
I think the answer to that is shortening transmission distance, hands down, single most appealing dimension there. I think, and I didn't provide a lot of context for our story. We may not be the largest energy complex in the country. We're the largest exporter of incumbent energy in the country to the tune of 2.5 million barrels of crude a day, second in LNG, behind Sabine Pass. So energy is sort of it's in kind of an existential part of our DNA. And I think, and there was a moment in time, 2 years ago when we had double-digit hydrogen and hydrogen derivative projects in the queue, equating to, in and of themselves, gigawatts worth of demand. So I think for us, the idea of minimizing transmission distances and all of the encumbrances that come with planning, designing, funding new transmission, only to then have assume the risk that comes with above ground transmission. So I think, the list is long in terms of attributes, but for me, that's the idea of again being able to plan not port wide, but really at an ultra local level, sort of within sectors and districts within the port instead of the port region in aggregate is really appealing.
I think having that flexibility of mobile will be great for the port. We all know what happened here in 2017 with Harvey. Harvey landed. It took us about 5 days to get the port up and running. And I know because I was active during that time, I was the chief of operations. After 5 days, I'm high-fiving my team. Hey, great job, everybody. We opened the channel. And then we got a call from headquarters why it took so long. The price of gas went up 20 cents in 5 days. 2 weeks after that, it went up 40 cents nationwide. So a lot of people were looking into what happened if we shut down the port for more than 5 days and we don't have the option of power. And now these facilities, it's not like you have a switch that once they shut down, you can turn it on the next day. It takes some time for these facilities to get back in line. So having the flexibility, have a mobile energy source that we can get out of the area during a hurricane or a heavy water event and then bring it back to the port and have the port up and running, I think that's going to be the need for the future. Have something like that we can rely for after an event, have the power available at all times to ensure our ports are up and running.
Excellent. So I guess the last thing that I wanted to address before we turned over to the audience questions returns to Admiral Servidio's presentation about port electrification. So in the calls for in addition to the call for reducing greenhouse gas emissions from vessels, ports have also been facing this challenge. And the EPA Clean Ports Program is an example of this, as well as all of the developments on shore power. But are there any other additional challenges that nuclear specifically can address in the process of port electrification?
I'll make a more general comment, I guess, in terms of the sustainability. I think Admiral Richardson made a really good point earlier, and it's more important now than it maybe was even 2 months ago, which is that with nuclear, you get the climate security for free. And I think it's really time that we need to capitalize on that. I think I'm disappointed to see the shift in the industry, whether that's banking or energy or other, away from sustainability goals, away from climate goals. I think now's the time we really have to dig in. And if the way to do that right now is through nuclear, which has all of these other benefits and it keeps us on track, even more reason to double down right now.
Yeah, likewise, guys, if you don't mind, just pile one point there. It's not just the climate action piece, it's also the criteria air pollutant piece. So, one of the sort of gating items and enabling items for us to be able to bring this industry to fruition is the social license to operate. And I can tell you, when you're dealing with 100-year-old public port authorities and quote-unquote fence line communities that are hypersensitized, you can't start that conversation early enough. And so the sensitivity around nuclear is sort of ironic in that nuclear addresses airshed insults that are the source of much of that sensitivity and have been for the better part of the last century. So I think that absolutely should not undersell the climate action and criteria air pollutant benefits of nuclear, and I think that has to be part of the way that we try to ingratiate communities to some of the things that we're introducing.
I guess what I would add is I do think nuclear brings the thermal capacity that could be used for synthetic fuels, for a whole bunch of other cogen types of things. And likewise, I think microgrids are probably a direction that the port infrastructure has to look at. And there's been significant challenges in Long Beach, California, in New York and other locations with just what can be handled by the port. New York was looking at electrifying the Manhattan cruise ship terminal, and it was just too complex and too costly. So they just didn't do it, despite what would have been significant public health benefits and other benefits. They just can't do it because the existing utilities outside the Southern Company's region just can't handle an awful lot of things.
You heard the Admiral when he said one cruise ship in Juneau is the equivalent of the city, right? And all I'm thinking is, in Galveston, we have 6 cruise liners. And as you know, the cruise ships are not getting smaller. They're getting larger by the minute. Now we have the Icon class coming our way with 7,000 passengers and crew members on board. Now you have 2 or 3 of those in Galveston. Guess what? That's 3 cities, right, Admiral? That are going to be down in Galveston. So once again, yes, we need to start looking into all that now, because this is not going to take time. This is going to be by November of this year, we're going to have at least 3 to 4 cruise ships down in Galveston any single day. So
the EPA shore power planning factor for a cruise ship, for a large one, is 11,000 megawatts.
Excellent. Thank you so much. I do think we have a few minutes for some questions from the audience. We might need to pass a mic back. Actually, let's see if any of these work. Okay, this I think. David.
Lauren, working now with Hyundai, Southern Company, TerraPower, those are like the best and the brightest. How soon are you going to deliver a multi-fluoride fast reactor to my backyard? How many megawatts can I get out of it? And what's it going to cost me? Because I'd like one tomorrow.
As soon as I can. I'm trying to build a small one in Idaho right now, and we're not going to stop work on a commercial one in parallel. And, one of the things that we've always thought has been really interesting about that technology, and this, is the scalability. I mean, it meets every one of the, capacities that we were talking about a second ago. It can scale all the way across each of those use cases, which makes it really interesting in terms of economies of number as well. So it may not be a small machine that shows up in a Connex box, but if you can deploy these across maritime, across industry, across electric power production, then that becomes really interesting. So still aiming for the 2030s, David.
Any other questions? Okay. I know the panelists will be around after, during lunch and during the coffee breaks. I wanted to offer my sincere thank you to them for participating and for your attention. It's clear that FNPPs are going to be able to provide a stable and resilient solution for the future. And the team at Core Power, myself included, are really proud to be leading this crucial conversation. So thank you again. Enjoy your lunch. But I think Toby will be the one who is officially dismissing you, not me.
Well, thanks very much, Joe and Sanjana. It's a really fantastic session. I think definitely the thing that resonates with me with something Lauren just said is about the scalability of this opportunity, right? The fact that as the power demand grows, as we've heard from the ports in those particular places, supply can meet it exponentially by adding those identical systems, has that flexibility to move where fresh demand occurs as well. Thank you very much indeed.